Welcome to Unacademy. Crack GATE computer science with us, top educators, quality content, great learning experience. Let's crack GATE CSE. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded courses from India's best educators. About myself, Srinivasarao Sir, having 17 years of GATE experience in the subjects of DBMS, CN, and OS, having industry experience as a database admin and a system admin. I also had certifications in database, Cisco, MCSA, and Red Hat Linux. Throughout my journey of GATE, I taught in many premium academies with a high success rate, including of single and double digit ranks. So my premium academies includes like GATE Forum, the GATE Academy, MadeEasy, and many others. If you get subscription, you will get daily live classes where you can discuss with your concerned educator and clarify your doubts, and blind test and quizzes. They are going to give you a lot of confidence, nothing but mock test, and they are having structured courses as per the syllabi and unlimited courses which consist of live and recorded courses. There are many courses are available as per a CSIT. You can happily take the subscription. There are two kinds of subscriptions. 12 months is costing around 25,000. If you apply my promo code, you will get it for 22,500. And 24-month subscription is costing around 30,000. If you apply my promo code, you will get it for 27,000. Those who are second year and third year students can opt for 24 months so that you will get double time repetition of your courses. So as far as DBMS subject concern, I am doing theoretical concepts on YouTube. This is a schedule which we are running since last 7-8 days back, which consists of full course of DBMS. And evening, I am running special classes on Unacademy student learning app. You can able to get it them. There we are going to discuss concept and MCQs and PYQs. So today's session is second normal form and third normal form. As far as last session concerned, we discussed about first normal form and the second normal form. So the difference between these two normal forms we discussed, 1NF mainly suffering from partial functional dependencies while you are converting multi-values to single values, and that we have to eliminate in second normal form. We understand 2NF redundancy is lesser than 1NF, therefore 2NF is somewhat better than 1NF, but still 2NF is also not completely reduce redundancy, as 2NF is also not completely free from redundancy because of transitivity nature. Therefore, today our session to create the benchmark between third normal form and the second normal form using the concept of transitivity dependency. So, what is a transitivity dependency and how it creates a duplication we are learning in this session, and how to avoid the transitivity dependency we also will see in today's lesson. So, second normal form is telling you that you want to be in a second normal form, you're supposed to be in first normal form. Then it is telling you that you must not have the concept of partial functional dependencies. So here if you get understand, 2NF is nothing but it must be in 1NF and must free from partial functional dependencies. And we learned that your 2NF redundancy is lesser than first normal form. As it is already cleared functional dependencies, it assumes that no partial functional dependencies, but it still suffers from transitivity nature. Because of partial functional dependency, the redundancy is removed, and because of transitive dependency, still redundancy is existed. So we can understand redundancy is existed because of transitivity in nature. So how we are going to identify that a transitivity in nature dependencies? If you look at this example, this is telling that it is in the transitive dependency nature. Why? Because if you observe the candidate key here, we can come to know that AB is a candidate key and there are two prime attributes are available. One is A and one is B, and the others are non-prime attributes. One is a C and one is a D. Therefore, we are trying to identify what kind of dependencies they are. If you observe that the first production, that is AB implies C, and the second production is C implies D, we come to know that as LHS is your candidate key, hence it is a fully functionally dependency. And if you observe this C and D, as they are belongs to non-key or non-prime attributes, so non-key versus non-key is telling you that your transitivity nature. The rule of transitivity dependency comes under into 2 points. One point is that your non-key is implying a non-key, it is a transitivity nature, and the other transitivity dependency, we speak that non-key with any kind of a combination of the attributes. It can be anything, but RHS must be non-key. In these are the two cases, we will consider that it is transitivity nature. Now, we want to identify what will happen if you are having a transitivity dependency. I said that it is 100% the concept of redundancy. All you need to understand one important thing, why we are doing normalization. Please observe. We are doing normalization because of only one important thing. You please follow previous my YouTube lectures. As the schema consists of duplication of data, that is called as redundancy, there are two kinds of reasons to occur the redundancy. One reason is functionally dependency and another reason is multi-value dependencies. These are the two important factors which are generating redundancy in your schema. I already shared how the FD is going to give you redundancy. Let me give one example here. MED we will see later. Let us learn how FD is going to generate the redundancy. If there is a production call, student number is giving student name, and the production is giving you like this, SNO implies S name. You want to prove this functional dependency in the sense this is called as a determinant and S name is called as dependent. Therefore, here what is going to happen? I am saying that S1, some student name like XYZ. When I repeat S1, then XYZ should come here. Then when I repeat this S1, then XYZ should come here, which indicates that functional dependency is one of the big clause to have the redundancy in your tables. You see friends, whenever S1 is repeated, its corresponding binding name should repeated. We know in regular life also, what is that? If I am saying Aadhaar number, this Aadhaar number is associated with only one person. There is a name Aadhaar number versus Aadhaar holder name. If I am saying Aadhaar number is A1, when I give to some XYZ, when I search for A1, then you are going to get only XYZ only. So using this kind of tips, we can understand that it is generating some sort of redundancy because you are successfully satisfying functional dependency. So functional dependency satisfaction is required and functional dependency also generates redundancy. This problem we could able to satisfy by doing a concept of normalization. What the specialty of the normalization? It has got a one tool. The tool name is decomposition. By doing the mechanism of decomposition, you could able to clear redundancy which is coming from functional dependency and which is coming from MVDs. And last session, I discussed like this, that whenever you talk about first normal form, it is suffering from some sort of redundancy. Whenever you converted decomposition into second normal form, then some redundancy it is cleared, but still you suffer from some redundancy. Why? We know this redundancy because of partial functional dependency, and this redundancy because of transitive dependency. So 2NF will be decomposed into third normal form. So therefore redundancy is cleared, but still some redundancy because of OD, and still 3NF is going to be decomposed into BCNF. Then when you reach to redundancy in BCNF, then you will get the redundancy from BCNF is what? 0. So what do we understand? We started with unnormalized. The meaning of unnormalized is nothing but which consists of use functional dependencies, and functional dependencies is going to generate what? Redundancy. And one more important, unnormalized is having more multi-values. Because of multi-values, you are going to have redundancy. Please see friends how this ladder appeared. Unnormalized converted to decomposed, that's meaning decomposed to 1NF, 1NF is decomposed to 2NF, 2NF is decomposed into 3NF, 3NF is decomposed into BCNF. So what is the difference between this particular point? The difference is we will confirm that you are free from redundancy because of multi-values. So multi-values removal is nothing but decomposition from zero normal form to first normal form. So 1NF and 2NF, if you understand, we will remove partial functional dependencies so that the redundancy which is coming from partial functional dependency is reduced in 2NF. But 2NF and 3NF, if you observe that because of transitivity, there is a redundancy. So we will decompose into 3NF by removing transitivity. And 3NF to BCNF, there is a still B3NF is having redundancy because of overlapping dependencies. Then we will say that there is no overlapping dependencies once you become to BCNF. That's why BCNF redundancy is 0. And once you observe carefully here that when you are saying that I am into BCNF, you say that you are cleared all your redundancy which is coming from the following dependencies. So friends, what I want to tell you, BCNF ensure that you don't have redundancy because of multi-values, you don't have redundancy because of partial dependencies, and you don't have redundancy because of transitivity, and it doesn't have redundancy because of overlapping. So BCNF is free from all these kind of dependencies. Okay friends, that's why the BCNF redundancy is 0. And another important point is like this. When I am restricted to third normal form free from redundancy, third normal form free from redundancy because it is free from transitivities, and it is free from partial functional dependencies, and it is free from multi-values too. In the same way, if I am saying that I am into second normal form, then you can say that it is free from redundancy. The 2NF is free from redundancy because of no partial functional dependencies and because of no multi-values. When you talk about the first normal form, you please observe that it is free from redundancy because of what? Multi-values. So friends, 1NF This is the constraint. 2NF, we want to clear the redundancy which is coming multi-values, and we want to clear the redundancy which is coming partiality. And what about 3NF? We want to clear the redundancy because of multi-values as well as partial dependencies as well as transitive dependencies. If you are talking into you are into BCNF, you know that we are free from all these kinds of dependencies. That's why what do we understand? We understand that once you reach to higher level normal forms, you are following lower level normal form rules like this, but without having any of its redundancy causing by respect to normal forms. Okay, friends. Now, so come to this example. This example is saying like this. So there are few attributes are there in employee table having some functional dependencies. So first let us identify your candidate key. As emp ID, emp name is giving you job. So your candidate key is emp ID and emp name. And there are two prime attributes in that. One is emp ID and one is emp name. And your non-prime attributes are the rest of the attributes. They are job and department name. Now, if you understand what is the normal form from there, I can say that your normal form using functional dependency. As first functional dependency, I am telling you emp ID, comma, emp name is implying job. So what do we understand? As this is candidate key and it is a fully functionally dependency, you can confirm that it is into BCNF, no doubt. So you look at the other production, job implies department name. So you please friends, your job is in a non-key attribute set, department name is a non-key attribute set. I already told you whenever there is a non-key and non-key, it is a transitive dependency. So we understand there is a redundancy, especially this particular production. So we want to break that redundancy by decomposing this production. So how to decompose? After decomposition, what are the steps to be taken? I will tell you now. So this is your important production which is having redundancy. And this is the production which is not having redundancy, no doubt. As your LHS is the key, this is a candidate key to you. Therefore, no redundancy in that. Now, our task is eliminate this redundancy using the component concept of decomposition. You observe friends, one more example. Book ID, book name implies author ID. Author ID implies author name. So we all know how to identify candidate keys. BID and B name is your candidate key. And your prime attributes are those two attributes. They are BID and B name. And your non-prime attributes are the rest of the attributes. They are AID and EA name. Therefore, now we want to identify, is there any redundancy? That's my question. My question is there redundancy? Please observe friends. I'm giving a question here. Is there any redundancy in the above book schema? In the above book schema. You all can respond from the chart. I will say that what? Yes. Why yes? As this is your candidate key, then you can confirm that this production does not have any redundancy. But this production is a non-key versus a non-key. then which is nothing but transitive dependency, then we can confirm that there is a what? Redundancy in that. Now, our task is to decompose this particular production into next level normal form so that we are free from normal, we are free from redundancy which is causing from your transitive dependency. So how to do? Let us see now. Please look at what the third normal form is saying. Third normal form is saying in such a way, every 3NF is supposed to follow 2NF. You all may have a doubt why to follow. You all may have a doubt why to follow because 3NF ensures that no redundancy which is coming from what is that? Partial functional dependency. That's why you say that 2NF assurance that no redundancy because of partial functional dependency. That's why every 3NF must be into 2NF. And 2NF also must take care that I must be into 1NF to ensure that I do not have any redundancy because of what? Multi-values. Therefore, 3NF must be in 2NF to prove that I don't have any redundancy because of partiality, and 2NF must be in 1NF says that I must not have the concept of what? Multi-values. Apart from that, 3NF also says that still I must free from a transitive dependencies which are causing from your second normal form. So the ladder is every 3NF must be into 3NF and sees that there will not be any kind of partial functional dependencies. What is the other important definition of third normal form? Third normal form is saying such that whenever there is a alpha implies beta production is there, to prove this production into third normal form, there are two conditions are there. Either of the condition can be satisfied. What is the first condition? LHS must be key. If this is the candidate key, then we ignore about the right hand side as it is a fully functional dependency. I can confirm that it is into third normal form. That's what. Your alpha must be either a super key or a candidate key for that R. If this condition is a fail, then need not be panicked. There is a one exception is there in the third normal form. That exception is that RHS must be your part of key. So if this condition is a fail, then RHS condition is there. The beta is supposed to be prime attribute. So this is a very important definition which you can prove ISC Bangalore previous two questions which are completely based on second rule only. What is the second rule? If it is fails the first rule, I don't mind. There is a second rule is there to prove that I supposed to be into third normal form. Okay, friends. So what are the very important properties? There are some shortcuts here. What is that? This is the shortcut. If there are no non-prime attributes in the relation, then you can confirm that it is into third normal form. This is the shortcut. When all the attributes are belongs to prime, that means no non-prime attributes, then it is into BCNF only. That is one shortcut. And another shortcut is that 3NF is the best normal form. Third normal form is a real-time industrial implementable normal form as it is offering attribute preservation, as it is offering lossless join, as it is offering dependency preservation. All the three properties you can clear off with the third normal form. That's why 3NF is the best normal form for any kind of relational database management systems. And other important thing, I already shared you that 3NF redundancy is lesser than 2NF because it's free from transitive dependencies. But the other important thing is that you please observe the second condition. You want to prove 3NF in the sense the key is supposed to minimum having two attributes. That's why your key is supposed to what? Composite. Why composite, friends? Observe the previous definition. See the RHS. What is your RHS? RHS must be part of key only. When you will get the part of key, if the key has got more than one attribute, then only that's called a composite attribute, and that composite key only you will get part of keys. If key is having, for example, like A or B, then you cannot prove the third normal form using the second condition. You want to prove the second condition in the sense you see that your candidate key is supposed to what? Composite. So I cannot prove when the candidate key is A using second condition. I can prove using a second condition when the candidate key is a what? Composite. So the key is supposed to be composite because only I can get that it is a part of key or not. I hope so you got my point. If not, listen carefully. I say your candidate key is A. Don't say that A is a part of key. It is a foolish. Please observe, friends. A is not a part of key. Everybody is having this kind of doubt only, even experts also. But A is not a part of key here. What is A? A is only what? Candidate key only. If I am saying my candidate key is something like AB, now I can say that there are two parts. One is A and one is B. Whenever key is a composite, then only you can say that using the second rule of third normal form, that is RHS is a prime attribute, I can prove. Otherwise, you cannot prove it. So, friends, what do we understand? Whenever key is a single attribute, don't say that it's a part of key. It's wrong. What is a composite key? Composite key is nothing but a key is identified with more than one attribute. For example, you say S number. If I am saying that it is a key, it is not a composite key, it is a candidate key, as well as you can also say that what? Primary key. But when I am saying your key is with a minimum two attributes like S name and S number, then you can say that the key is being computed on two columns here. So therefore, your key is not a single attribute. Your key is a two attribute. One attribute is S name, one attribute is S number, and so together we are identifying the uniqueness using this only. That's why it is a composite. Okay. Otherwise, look at one more example. There is a S number. Observe. I am saying this is the candidate key. So your candidate key is a simple now. It's not a composite because I able to identify single column. I am giving data S1, S2, S1. It's a duplicate. Candidate key disallows duplicates. Please understand, friends. Candidate key will not accept duplicates. Understand? Because every candidate key, either it can be a primary key or either it can be a what? Unique key. So every primary key and every unique key belongs to what? Candidate key only. So candidate key consists of data unique. You cannot find any kind of redundancy in that. Now I am writing one more. I say S number and S name. Together I want to form uniqueness. Now my key, my primary key is, now please understand friends. Now my primary key is S number and S name. So here I can enter S1. Please observe carefully. I can enter S1. I can enter S1. No doubt. Individually we are not checking the duplicates in this. So now if I am giving X, Y, Z, I cannot give one more time X, Y, Z. So I am giving A, B, C. Then I am giving something like M and O. Now you see, if anybody asks you, is there any redundancy? We will say that all the three tuples are what? Unique. Why they are unique? Because your key is based on S number and S name. Individually you can have duplicates, but overall you suppose not to have duplicates. All the three rows are unique. This is the difference between simple candidate key and composite candidate key. So here your key is composite. Composite is nothing but a key is defined on more than one attribute is the concept of a composite key. Clear, Ajay? Yeah. Listen, friends. And one more important point that 3NF assures that 3NF assures that you don't have redundancy because of partial dependencies, and you don't have redundancy because of transitive dependencies. Because already we see the ladder. Please observe this ladder. When you are into 3NF, in the sense there is no transitive dependency, there is no partial dependency, there is no multi-values concept. Okay, that is the point is written here. What is that? 3NF eliminates both partial and transitive, therefore redundancy caused by them is cleared. But what is the problem with 3NF? Because of rule number 2, observe carefully. This point is because of rule number 2. What is rule number 2? Overlapping dependencies are allowed. What is the overlapping dependencies? Overlapping dependency is nothing but what the rule number 2 is saying to you. Rule number 2 is saying to you that RHS must be part of key. RHS must be part of key. So because of this, RHS must be part of key is the concept of overlapping dependencies. Okay. So we already discussed this. We come to know that this is transitive dependency and this is fully functionally dependency, as this and this is a candidate key, this is the non-key and this is a non-key. So there is a redundancy, especially in this point. So we want to remove that redundancy. We are removing in this example. Please observe. Now we are removing in this example. I said that there is a redundancy, especially this production. Author ID and author name is a redundant production as it has TD. Friends, you need to understand clearly one important point. When I am talking about redundancy, again and again I am telling you, please get clarified. It may be with the multi-values, it may be with a partial functional dependency, it may be with a transitive dependency, or it may be with the overlapping dependency. Anything is possible which is causing what? Redundancy. In this example, the non-key implies non-key generates redundancy because as it is belongs to redundant causing factor. So this particular column which I am highlighting, this author ID and author name, you will find the redundancy. How it is giving redundancy, let us look at in the next. Please observe. This is the book table which consists of book ID, book name, author ID, author name. So I am also taking that book ID, book name, author ID, author name. So two dependencies are mentioned. What is the first dependency? Book ID, book name to author ID. Book ID, book name to author ID. Second dependency is author ID to author name. So author ID to author name. Observe friends clearly. This LHS book ID and book name is a what? Candidate key. So we understand the previous, go to the previous, you will come to know. Book ID, what is your candidate key here? You know how to obtain the candidate key. Book ID and book name together is your candidate key. I confirm that this candidate key is not a single, it is a what? Composite, because it is been built on more than one attribute. It is built on more than one attribute, hence it is called as composite candidate key. Please observe. That means we see the uniqueness based on book ID combination as well as book name combination. Okay, now come to this point. You see that this is a candidate key for us, and this is non-key implies non-key which is having a TD, This TD suffers from redundancy as I am highlighting once again, but there is no redundancy here as your LHS is the key, no doubt. So observe now. Book 1 database unique tuple. First let me cross check this production. Book ID, book name production I am checking once again. Book 2 Java unique production. Book 3 Python unique production. Book 4 C unique production. Book 5 Unix unique production. Book 6 .NET unique production. All are valid tuples as there is no redundancy among book ID and book name, as book ID book name is a candidate key. For example, if I generate once again book 1 and database, it will give you error that already book 1 database is available in the table, so you cannot give it. But I can give like this. If I am saying book 1 and C, this is a valid tuple because book 1 and C combination is not there earlier. So friends, what do we understand here? If I am saying book 1 and C, this is a valid tuple, but book 1 and database is not a valid because already it is available in the database, right? So as far as that production concern, we are not worrying because as your candidate key is appeared, we understand no redundancy in that. But come to the very dangerous transitivity. What is the transitivity? Author ID to author name. So here what happened? A1 author name is Ram. That means Ram is given number as author 1. James name, author name is given a number A2. Next, Gosling is given a name number to A3. Now you observe carefully, friends. A4 Richie. This is also valid tuple. But you understand, whenever author ID LHS is repeated, what is the meaning of functional dependency, friends? Please observe. AID implies A name means if LHS is not a candidate key, then you will get the redundancy here. If LHS is the key, then it's not a concept of transitivity at all here. As LHS is not a key, then what you supposed to do, I am proving whether this functional dependency is proving or not. How to prove? Ek bar dekho. I am giving A1. The name is Ram. Okay. Next, I am taking A2. A2 is a James. This is a functional dependency happened as AID is unique tuples. But when I generate A1 once again, please observe, as AID is not a key, it can allow duplicates in this. So whenever A1 is repeated, the bound author name has to repeat. It has to, otherwise it is a invalid functional dependency. So to prove this functional dependency, whenever A1 is coming, Ram has to come. That's what. So please see, whenever A1 is coming, this associated name has to come. Again, whenever I call once again A1, then automatically you have to repeat Ram also here. This is the naturality of functional dependency. Otherwise, the schema is going to be invalid. Okay, friends. Why? You may get a doubt that why functional dependency is to be proved. Please listen. One real-time example I will tell you. There is a bank database. This bank database, if you go, bank account number is one of the first important column to you. Naturally, this will not allow duplicates, hence we will call this as a candidate key. So account number 1000, account number 1001, account number 1002. I cannot give 1000 once again. This is invalid. Why? As you already identified what? It is a candidate key. Okay. Now account holder name. Let us write. The account holder name is something like ABC XYZ and something like MNO. So when you go to the bank, they will ask you what is your number, account number. If I am saying that I am the representing ABC, then when you say that my account number is 1000, then automatically ABC details only will come, no other details will come. So what do we understand? We are proving this functional dependency such that what your bank account number will give you bank holder name. But here, as far as you are proving that it is a candidate key, you cannot re-get this value. Why? Because it's already what? Candidate key. If you not say that it is a candidate key, now what will happen? Now I can clear. Whenever you call 1000, then what will happen? The other guy is going to respond. So who is going to respond? When I'm calling 1000 here, as the rules of functional dependency, ABC has to respond. Therefore here account number is implying account holder name. As whenever you call 1000, only he will only respond, others are not going to respond. This is what in banks you have the concept of token system. The token system is also same. Whoever is having the token, that guy only will respond, remaining is not supposed to respond. This is the concept of proving of functional dependencies. So come to the previous. So what do we understand? We understand that if LHS is the candidate key, you see that there is no concept of redundancy here, but because of transitivity nature, you find the redundancy author ID and author name as this is a proof. So whenever A1 is repeated, then its author name has to repeat. That's why there is a redundancy because of what? Transitive functional dependencies. So this redundancy we want to remove. How to remove this redundancy? What I said, you want to remove any of your problematic dependencies, then you're supposed to do what? A decomposition concept. So I am using a decomposition concept in order to avoid redundancy which is coming in this particular production. So the first subtable I am creating a what? Author ID and author name only. Please observe. So let us see important point, redundancy in a book table due to transitive dependencies. To avoid redundancy from the transitivity, remove transitive functional dependency production, that is author ID and author name. So decompose a book table. You will get two tables. One table, any name you can keep, book 1, which is author ID, the production, author ID to author name. So author ID one production, author name another production. The other second table, book 2, rest of the table. What is the rest of the table? You see that book ID, book name. That is only your rest of the table. Book ID and book name. So as I subdivided into different tables, both are independent tables. This is the separate table. This is a separate table. In this, AID is a candidate key. Please observe. In this, BID and B name together is a candidate key. Okay. So you will find no redundancy in that as AID is a candidate key. You will find no redundancy in this as BID B name is a candidate key. So friends, whenever you have a table consist of candidate keys, in that candidate key column or a columns, you cannot have duplicates in that. So I have also posted the data. Observe carefully. Please see. This is your first table. What is your first table? Decomposition 1, which consists of transitive dependency production only. I am making them into a separate table. Author ID, author name. As it is highlighted, it is a candidate key. Why it is a candidate key, friends? Observe. Why it is a candidate key? I am saying author ID closer, you will get author ID and author name. This is nothing but your decomposition 1, which is giving you R1. Therefore, AID is the candidate key in that. When I am saying AID is a candidate key, observe carefully. Please, all of you, look at. I am filling the data now. Data also must not lose. That's very, very important. While doing decomposition, data must not lose. Dependencies must not lost. We need to prove that 100% it is a lossless join only. So I am filling all the data A1, A2, A3, A4, A1, A1. And the same author name also I will fill like that. Observe. A1 against name Ram. A2 the name is James. A3 the name is Gosling. A4 the name is Richie. Which doesn't require. Why? Already A1 is a present and I said that A1 is a candidate key. Earlier it was not candidate key. That's why there are some duplicates. But I made this one as a candidate key, hence no duplicates in that. So this is not possible and this is not possible. So far, these rows are what? No duplicates, no redundancy in that. All tuples are unique in this. Clear? So after decomposing your book table, your transitivity functional dependency is removed and the redundancy is eliminated because your table consists only two attributes only, not all the attributes. Rest of the attributes we are pushing onto another table. What is another table? This is your another table. Another table consists of book ID and book name. You forgot about this. Other table consists of book ID and book name only. So I am writing book 1 database unique, book 2 Java unique, B3 Python unique, B4 C unique, B5 CC unique, B6 .NET unique. But you observe whenever you do decomposition, you need to say that there must be a common column between your master table and child table. In that case, you please observe your decomposition. I did the first table with the book 1 and I did second table with the book 2. In book 1, your AID is a what? Candidate key. In book 2 table, you have book ID and book name. There are two attributes. These two attributes are saying that they are combinedly candidate key. I am preserving old dependencies, friends. Please understand carefully. This is the candidate key as it is given in the original relation. As we made this is a separate table. Earlier AID was not a key. Now I am saying that this is the candidate key. Therefore, you cannot have duplicates in that. So what are the tuples are there in the B1, A1, A2, A3, A4. So I will fill here A1 and A2 and A3 and A4 non-redundant data and BID B name. So B1 something like and B2 and B3 and B4 and B5 and B6. Okay, data I filled. When I merge these two tables, that's the meaning of decomposition. When I merge these two tables, you're supposed to get a concept of what? Lossless join. Data exactly supposed to be as it is given to original table. Data must not lose. What is your original table? You please understand this is your original table. You have to get this form without having any kind of duplicates. So I am trying to merge whether my decomposition is best or not. In order to prove this lossless join, what is a common? The decomposition is saying that there is a requirement of common column. Now you have a doubt which one I should use as a common column. So this candidate key is trying to use this side as a foreign key. Therefore, now you can have this combination. So as it is, I have written this table here, you understand. So A1, this is given A2, A3, A4, A1, A1. Same data, by merging book 2 and book 1, you will get the first given original table only. This is your original table. And now after decomposition, we come to know that two different tables we got. 1, decomposition 1, without having any duplicates in that. Please highlight that. No redundancy. And here also, in this table also, there is no redundancy in the LHS columns like this. Okay, friends. So this is what is the concept of identifying transitive dependencies and how to eliminate transitive dependencies. Okay. And if you have still doubt, please follow decomposition topic YouTube lecture as well as special classes lectures. You will understand what is a lossless join, what is a dependency preservation. I already covered in those lectures. So come to next. So using that knowledge, you can simply remove the transitive dependencies. How I remove? Observe carefully. The candidate key here is S. Okay. S implies T. As S is a candidate key, this is a fully functionally dependency. This is the first production. And the second production, T implies U. As it is not a part of your candidate key, hence both are non-keys, you can call it as TD. And the third one is U implies V. As they are not part of your key, so non-key to non-key is also transitive dependencies. Now friends, my question is there redundancy? Is there redundancy in relation R? We will say 100% yes. Why? Because of they're not all fully functionally dependency. Some are having a troubles because of existency of transitive dependencies. So what to do? You have to eliminate this. You have to eliminate this. So now you will get 3 decompositions. One decomposition for this failure property, another decomposition for this failure property, and another decomposition for your fully functionally dependency. You will get 3 decomposition this time. What are the 3 decompositions? One is T and U. This is a one table. And another table U and V. And another table S and T. Please observe. So to remove your transitive dependency, decompose it. So after decomposition, I got independent table of TU, which is not a part of R, independent table of UV, independent table of ST. Okay. Now pull those dependencies. I am writing here your R1, your R1, TU, UV, TU, your R2, UV, and your R3, rest of the table, ST, your R is STUV. Now, I am pulling the production. What is the production? Failure production. Because of this only we got TD there. Please observe. Because of this it is a TD. Now I have removed that. Because of this production it is a TD. Now I have removed that. This is a separate table. This is a separate table. And this is your separate table. Now, this is already S implies T. So I am also preserving dependencies. The meaning of dependency preservation is nothing but all the 3 given dependencies you need to preserve. S tends to T is existed in R3, U tends to V is existed in R2, T tends to U is existed in R1. Therefore, we will feel that I am preserving all the given dependencies. Now you see what is your candidate key in this, what is your candidate key in this, what is your candidate key in this. As the tables are different, you will get different candidate keys. How I shown you in the previous. What is that? Please see. Here, As this is a separate table, AID is the candidate key. In the same way, you see that the candidate key is a separate. What is your candidate key? Your T closer will give you TU, which implies to R1. Therefore, T is a candidate key. This is enough. Come to the next. As I am finding U closer, the U closer will give you UV. Therefore, this implies to R2, hence U is a candidate key to this table. As I am finding S closer, the S closer is giving you ST, which is giving you to R3. Therefore, SC is a candidate key. Bus. So you see friends, you cannot have duplicates in T, as T is a candidate key. You cannot have duplicates in U, as U is a candidate key for this. You cannot have any duplicates in S, as S is a what? Candidate key. So now you observe friends, LHS is the candidate key, LHS is the candidate key, LHS is the candidate key. Therefore, they are all not transitive now. They becomes what? Fully functional dependency. In fully functional dependency, the redundancy is 0. Okay friends, so this is how you need to remove transitive functional dependencies using the component concept of decomposition. Clear? Now you cannot have redundancy in T, you cannot have redundancy in U, you cannot have redundancy in this S. So after merging your R1 and R2 and R3, then you will get what? Lossless join. Clear? Next. So this is the example. Yeah, I will clear Rahul Joshi. Wait. Joshna. 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 One see, one of our friend is asking, Joshna. So one of our friend is asking, so teacher ka code asked. So you see, this is a teacher code and this is your teacher name. So I say, for example, subscription code T1 and this is XYZ. Okay. Now you observe carefully. For every teacher, there are some referral bonuses. For every teacher, there are some referral bonuses. Clear na? Now you see, when I am saying T2 and his teacher name is ABC, if any student is using T2 referral code, this bonus amount has to go to T2 only. So therefore, for example, you see there is something like 500. And when I am using a T1, using some other referral code like XYZ, so you will get a referral code something like 500. So whoever subscribed this, he has to got another 500. So here also we are proving such that your teacher code implies bonus. So you will come to know that this bonus is belongs to which teacher code. That's the point. So whenever T1 is repeated, then the corresponding bonus amount has to be deposited in corresponding teacher's code. That's why there is a requirement of what this kind of functional dependencies, why to use separate promo codes. So to identify that the student belongs to corresponding teacher, not others. For example, you say there is a student number, you might be given a numbers there. Student 1 is joined using a T1 subscription code, and student 2 is also joined using a T1 subscription code. Therefore, I will come to know that T1 has got two referral bonuses using S1 as well as S2, and I can come to know that how many students are joined against to T1. I could able to say this. That's why we are maintaining a concept toward referral codes. Okay, now come to our previous example. What is this? Now you need to find out the candidate keys here. So one LHS is XY closer, and how we will be benefited from them. So you are getting 10% off by using subscription code. You will get a benefit as well as faculty also will get benefit. This is nothing but tagging of the students against to the concerned faculty. So mutual benefit to each other. Yeah, come to the point. So XY is a closer and Z is a closer. Now you see Z and Y. So in that case, CS tends to Z and Z tends to C if I am writing, or otherwise you can change your table as XYZ. Now which is not appeared here, ZY, X is not appeared. If I add X here, already X is present. Now you will get XYZ and you will get XYZ. Now therefore XY and XZ are two candidate keys. Now your part of keys are nothing but prime attributes XYZ. I already gave you one hint. Your non-prime attributes are nil in that case. Therefore, I can confirm it is a what 3NF because of it is in 3NF because of overlapping dependencies, and it is not in it is not in BCNF because of overlapping dependencies, but it is in 3NF because of transitive dependencies. So as there is no transitive dependency, you observe that XY implies Z. This is the candidate key, which is a fully functionally dependency. And the second production is Z to Y. So Z is a part of key and Y is also part of key. So part of key implies part of key is the concept of overlapping dependence. So as he is asking what is your normal form, we can confirm that it is into 3NF as there is no transitive dependencies. So come to this. This is also very same scenario. Now we are going into questionnaire. Observe carefully. So candidate key we are going to calculate. I am finding here CN closer and DN closer and C closer. Right hand side DP is available. The missed one is CN. So find CN closer. CN will give you P and C gives you D. This implies your R, and DN closer DNP, and what else? DNP. So you want D, already D is there. What you want? C is required. So C is not possible. Hence this is not giving you R. So we can come to know that Cn is a candidate key. And your prime attributes are C, comma, N, and non-prime attributes are, observe friends. Your rest is that. What is that? D and P. Okay. Now you see, let us understand the production meaning. The first production, Cn to P. As this is a candidate key, it is a fully functionally dependency, no doubt. And a second one, so you can confirm directly in BCNF. Second one, Dn to P. You observe carefully. And third production, C implies D. So what is a C? What is a D? Let us examine. Your C is part of your key and D is non-key. Observe carefully. And here, what is Dn? Dn is, N is a part of key, D is a non-key, hence it comes under into non-key only. It's a non-key implies, what is a P here? It is also non-key. Now you see friends, three different varieties of dependencies in this question. One is fully functionally dependency, another one non-key to non-key transitive dependency, another one part of key to non-key partial functional dependency. So friends, please observe the ladder. What is the ladder? You want to say that BCNF, you suppose not to have overlapping dependencies. You want to say that you are in 3NF. You suppose not to have transitive dependencies. You want to say that you are in 2NF. You suppose not to have partial functional dependencies. You want to say that you are in 1NF. You have to say that I don't have multi-values. Now you can decide what is the normal form you're having in this example. So I am restricted to 2NF because I am suffering from, one is with TD and one is with PFD. Because of TD, we are restricted to 2NF, and because of PFD, we are restricting to 1NF. Hence, your final answer, this is your best normal form or highest normal form or least normal form. You need to say only lowest one only, whatever you achieve. So our answer is 1NF. As you are suffering from PFD, even though you have transitive production and fully functional dependency production, because unless you clear the PFD, you cannot say that you are in second normal form. That's why in this question, your normal form is 1NF. So come to questionnaire. So this questionnaire we will solve. Now you observe. What is the highest normal form satisfied by R is? So candidate key computation is very important in this. So I am doing AB closer and D closer and BC closer. So A, D, E, C, D all are appeared. Only B is missed. Attach B. So AB closer is giving you A, B, C, D, E, and BD closer is giving you B, D. As I have D, I will get A. As you have A and B, you will get rest of the thing. And BC closer, write BC. BC will give you DE, BC, DE. As you have D, you have got A also. Now, your candidate keys are here AB and BD and BC. So, your prime attributes are, please write every time prime attributes A, B and C and D, and your non-prime attributes are They are available. So I am unable to prove that it is 3NF or not. You need to go for manual proof only. What is the manual proof? Take it. Your manual proof like this. AB implies CD. As this is a candidate key, I can confirm it is a fully functionally dependency. When I am saying fully functionally dependency, I can say that there is no duplicity. And the second production is D tends to A. D implies A. What is a D here? Your D is a part of key. A is a part of key. Observe friends. So part of key and part of key is nothing but what? Overlapping dependencies. There may be a chance of what? Redundancy in this. So duplicity is there. And the third production, BC implies DE. This is the first production. This is second production. Now I am writing third production. Observe carefully. Your third production is BC implies DE. What is your BC? Your BCs are part of keys only. Please observe. So part of key implies what is DE? D is your part of key. What about E? E is your non-key. Bus. It's gone. What's gone, friends? Observe carefully. There are two productions in that. I am writing once again. Carefully listen. There are two productions in that. Yeah. Yeah. Thank you, Ajay. Very nice. So BC implies DE. Then as BC is a candidate key we obtain, then we can confirm that as it is a candidate key, then it is a fully functionally dependency. Thank you. Now, because of this overlapping production, now we come to know that overlapping will give you duplicity, and this will not give you any kind of duplicity. There is no duplicate. Hence, your normal form is finally restricted to third normal form because of this production. Okay, so come to the next question. So we will see some of the candidate case. In this, I am finding AB closer and C closer and BC closer and ACD closer and BE closer and EC closer, CF closer and D closer. This is a very, very rare situation. So C appeared and A appeared and D appeared, B appeared, C appeared, F appeared, E appeared. So we start find the closer directly. So what is AB closer? AB closer will give you ABC, BC will give you D, and ACD will give you B. What else? ACD will give you B. As I have D, I will get E from here. As you have EC combination, you will get AF. So you got ABCDEF. So one candidate key is AB. Okay. Now what about C closer? You find the C closer. C closer is CA. Now what else you can find? So to get C, AB is required. To get D, BC is required. To get B, ACD is required. To get C, BE is required. To get AF, EC is required. To get BD, CF is required. To get E, D is required. So NF. What about BC closer? Take BC closer. BC will give you D, and BCD we have. So as C is there, you will get A. So whenever you have A and B combination, you will get these things. So you will get A, B, C, D, E, F, no doubt. And ACD, What about ACD closer? ACD here. ACD will give you B. As I have AB combination, it will give you other attributes, no doubt. And BE closer, BE will give you C, and C will give you A. As I have A and B combination, you will get once again this A, B, C, D, E, F. And what about EC closer? I have EC with me, and the EC will give you AF. And what else? I have CF, I will get BD. C and F is there, I will get BD. Therefore, it is also giving you R. What about CF closer? CF closer, CF is there. CF will give you BD, and D will give you, C will give you A. So as I have AB, you will get rest of the tuples. And what about D closer? D closer is giving you D, and D will give you E here, DE. What else? So to get BDCF, AF means EC is required, we don't have. C means BE is required, B means ACD is required, D means BC is required, A means C is required, C means AB is required. That's it. Now your candidate keys are AB is a one candidate key, BC is another candidate key, and BE is another candidate key, and EC is another candidate key, CF is another candidate key. So you please write those candidate keys AB and BC, and ACD is also giving you R. ACD, AB is different, BE is different, EC is different, CF is different, and this is also one candidate key. ACD combination is not there anywhere. So therefore AB and BC and ACD and BE and EC and ECF, they are all your candidate key. Now let us examine the productions now. So this is the candidate key, and BC is your candidate key, ACD is your candidate key, BE is your candidate key, EC is your candidate key, CF is your candidate key, and what about D and E we want to check, C and A we want to check. So C to A, prime attributes, they are part of key implies part of key, so overlapping dependency. And next one is a D to E. What is a D? Your part of key. What is your E? Your part of key. So overlapping dependencies. Hence you have redundancy. Then you are restricted to 3NF because of overlapping dependencies. The answer is not in BCNF but in 3NF. This is your answer. Not in BCNF because of what? No, because of overlapping dependencies. It is in 3NF because of no transitive dependencies. Come to next question. So our candidate keys we will confirm here. AB closer, AC closer, B, BDC, BCD, A is missed. So AB will give you R, no doubt. AC will also will give you R. So AB and AC, two candidate keys. So your prime attributes are A comma B comma C, and non-prime attributes are, that is a D. So candidate key, B is a part of key, C is a part of key, overlapping dependencies, then 3NF. Come to this. This is our regular question. There are two candidate keys, name CNO, and RNO CNO. So this is a candidate key. This is your candidate key. This is your part of 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 key. Overlapping dependencies. Normal form is 3NF. To come to this question, your candidate key is AB. Your super key is ABC. So let us find candidate key AB, ABC and C, EC, CD. So CD is missed, AB is there. You attach AB. So this will give you R, this also will give you R. So your prime attributes are A comma B and non-prime attributes are rest of the attributes C, D, E. So as the first production AB tends to CD, candidate key. Second production ABC tends to E, super key. Third production C tends to E, non-key, and E is a non-key. Non-key to non-key transitivity. Because of this, we are not in 3NF because of transitivity, but in 2NF because of no partial functional dependencies. So come to next question. Your candidate key AB closer, C closer, ACD, B is missed. So this gives R and this gives R. So AB and BC. So AB tends to CD, candidate key, fully functionally dependency. C implies A, part of key and part of key, overlapping dependencies. Therefore, we are restricting to third normal form. Next question, candidate keys AB here and C here and D here. CDE, AB all are appeared. AB closer is giving you R. C closer is giving you CA. What else? Nothing. D closer, DB. Therefore, your candidate key is AB. So your prime attributes are A comma B, and the first production AB tends to CDE. This is the candidate key. C tends to A. C is a non-key. B is a part of key. Therefore, third normal form rule number 2. This is the next one. D implies B. D is your non-key. D is your non-key and B is your part of key. Rule number 2 of third normal form is satisfied. Okay friends, so finally we will confirm it is in 3NF. Next question. This is our last question. Your candidate keys are ABC and D. D and A missed. Attach BC. So this gives you R. This also will give you R. ABC and BCD. First production ABC tends to D. Candidate key. Fully functionally dependency. Second production D implies A. Part of key and part of key. Overlapping dependencies. Hence we are into third normal form. And this is our last question friends. So let us find A closer, B closer, E closer, G closer, C closer. So what are missed right side? D appeared, F appeared, H appeared, G appeared. The missed one is EAB. So EAB attach. Yeah. Now you see friends, EAB, they are all same. It will give you R. This is a super key and this is a super key. So your candidate key is EBA. So come to the first production, non-key. Then it is a partial functional dependency. Then you can say that it is into first normal form. Okay friends, so this is how you can eliminate the concept of transitive dependencies, and the transitive dependencies are mainly leads to redundancy. So what you supposed to do is just you do only decomposition of that. So whenever relation has a transitive dependencies, you create a separate table for the transitive dependency table, and the rest of the table R2 is your R minus your TD. This is your logic. What is the logic? If the entire table is R, you create a separate table for the TD, and the rest of the table is R minus TD plus candidate key of R1. This is very important point. R1 is a TD, R2 new table is a what? R minus TD production plus candidate key of R1. Because once you merge this R, there is a common column. This common column only we are using here. Therefore, this will tell you that it is a what? Lossless join. In the same way, last session we did using like this. If there is a relation consist of PFD, you create a separate table for PFD. And the rest of the table is a what? Your R2 is your total R minus your PFD production plus candidate key of your R1. This is how the concept of a decomposition. Create a separate table for every failure production and use the candidate key of that into other instances. That's it friends. Stay tuned to us for upcoming lessons. Use my promo code to get 10% off, and subscribe to our channel. Let's crack GATE. And if you not took admission, please use my subscription to get the 10% deduction and get the subscription into Unacademy, so that you will get live and recorded lectures and many more